Okay, folks, this is going to be a video that's going to give you just a few hints for the level 1 and 2 part of the momentum assignment. So let's just go through each question. Level 1, question number 1. You're calculating impulse, J, which is equal to the change in momentum. So there's two ways that you can do this when you're dealing with impulse. You can either use the formula that J equals F delta T, or Ft, how much the time changes and the force applied. Or you can realize that impulse is also just delta P, which is equal to P2 minus P1. So you just look at the question. If you're dealing with a question that's giving you forces and times, use this approach. But if you're dealing with a question that's giving you masses and velocities before and after, then use this approach right here. So in question 1, it looks like we're going to use this approach because we have a force and a time, and it's a plug and play. But in question 2, so there's question number 1, but in question 2, they're talking about speeds and masses. There is a time given, but without the force, that time is kind of useless. So that time really doesn't matter to us. Now, there could be a part B to that question where you could find the force. Once you calculate the change in momentum using P2 minus P1, you could then set that equal to, right? If you look at those two equations, then F delta T is equal to P2 minus P1 because they're both equal to impulse. So that could be like a part B, which is not on the assignment, but down the road, that's what could happen. So that's the hints for 1 and 2. Question number 3 is simply just using momentum and MV. So that shouldn't be too hard. So okay, there's level 1, nice and simple plug and play. Level 2, things get a little bit trickier because we have to think about reference frames. So here we have two balls, right? And there's going to be a collision. So the way we handle collisions is by using the law of conservation of momentum. Hopefully you've watched the videos. P total before equals P total after. We use the prime sign for after. So we write the momentum before, which is the mass of ball 1 and the velocity of ball 1, plus the mass of ball 2 plus the velocity of ball 2. And that equals the mass of ball 1 and its speed after, plus the mass of ball 2 and its speed after. Now just be careful when you put in the numbers that you are watching the directions for left and right. Okay? Remember that lefts are negative and rights are positive. Except that I notice in the... yeah, okay, it should be fine. I'm okay. So you have one ball moving at 7. Now the masses are equal in this case, right? All the balls have the same mass. So this is, okay, first of all, I see, I kind of got a little too excited there. There's no plus there. M2, V2, let's fix that. Okay, good. Now, you can cancel out the masses because the masses are all equal, but you can only do this when all the balls are the same, because we're essentially dividing both sides by mass, and every term gets the mass divided out. The V1 of the first ball is 7, and it's to the right, so plus 7. The second ball has a velocity of 4, but of course that's a minus 4, so that's going to work out to be minus 4 on this side because of the velocity of 4 that's to the left. You can see it in the picture. And then after, you have V1, the ball on the left, which is the 7 meter per second ball, is now moving at minus 3, and you need to figure out V2 prime. And the signs should work out for you. So there's question 1. Watch for the signs. Question 2, the arrow emerges on the other side of the apple with velocity. Again, P total equals P total after. P total before, P total after. Momentum before equals momentum after. And the way we do that is we set it up again. The momentum of the apple and the momentum of the, unfortunately, arrow and apple are both start with A. So for the arrow, I'm going to just use a little arrow. Nope, that's confusing too because it'll get all messed up with my other things. So let's just pick something else. Let's call it the projectile. There, P equals momentum apple after plus p projectile after. Mass of the apple, velocity of the apple, mass of the projectile arrow, velocity of the projectile arrow. And we continue on same way as we did before. After projectile arrow, velocity, projectile arrow after, right? You don't have to worry about the mass after, because in this case the mass isn't changing. However, there are instances where the mass does change. We'll see that in a minute when we talk about another question. So you don't worry about the mass after, but if the mass were to change, you'd have to change those masses into whatever masses you had after the collision as well, right? But we won't worry about that right now. Now you're just going to plug and play and solve that one. And that's it for level 1 and 2. I'll do another video with hints